Welcome back to the physics class, my dear students. As you know, in the previous class I said there are three equations of motion. And that you can observe that the first one is S is equal to ut plus of at square. The second one is v is equal to u plus at. The third one is v square minus u square is equal to 2as. When we come towards the terms which are present in these equations of motion, let us see one by one. Whereas S is said to be the displacement covered by the object when it is moving from one point to another point. As well as even we have another terms like u. U is said to be the initial velocity. U is said to be the initial velocity. And next there comes A. A is called as acceleration, and the small t represents the time taken by the object. And the last one is V, that is said to be, V is said to be final velocity. Final velocity. So these are all the terms which comes under kinematic equations of motion. So in the previous class I said you that to understand this kinematic equations of motion, we need velocity time graph. In that velocity time graph, I just shown you 3 or 4 types of graphs in which you observe that the increasing acceleration, that is said to be the uniform acceleration, as well as uniform retardation. With that even you observe the object which is moving with uniform velocity. So one graph indicates the object moving with uniform velocity, the second graph shows you that uniform acceleration, and the third graph shows you the uniform retardation. And even I just show you that the object which is moving with the constant velocity. So these are all the graphs that I have shown you in the previous class. With that, even I said you the area under the VT graph, area under the velocity time graph gives you, see, if we just calculate the area which was present in the VT graph, we'll get the displacement. We will get the displacement. Similarly, suppose if we calculate the slope, in the last class I showed how to calculate the slope and all. So that the slope of VT graph, gives you the acceleration. It gives you the acceleration. So hope you got that by just calculating the area under the velocity time graph, we can easily find out the displacement. Similarly, just by calculation of slope, we'll get the acceleration. Now to derive these kinematic equations of motion, these 3 equations of motion, I am just moving with the velocity time graph. See my dear students, I am just writing 2 coordinates. One is said to be x-axis and another one is said to be y-axis. Then along x-axis, I am going to consider time, that is represented by symbol small t. And here there is a presence of origin represented by O. And along y-axis, I am going to consider velocity. And along y-axis, I just consider velocity represented by symbol V. Now, observe that the object is moving from point A to point B. Right? It is moving from point A to point B. See now, with some initial velocity. So you might have observed in the previous class, I show you the 2 different graphs, whereas the object which is moving with a uniform velocity with 0 velocity, with 0 initial velocity, and as well as I show you the graph that, so even just now I can show you now. So if the object is moving with uniform velocity and with 0 initial velocity, this is the graph. Whereas the object which is moving with some initial velocity, so this is said to be the graph. It means here the initial velocity is 0, whereas at this point we can observe that some value is present because here it is 0 now. Suppose if the object starts from here, it means the initial velocity is 0. Suppose if it is like this, so this shows that the object is moving with some initial velocity. Here u is equal to 0, here the initial velocity is present, right? Here initial velocity is present. Now the similar thing I am using here to explain. So now I am just considering an object which is moving with some initial velocity. So that the initial velocity is u. It is moving with some initial velocity. Let us name that as u. So it starts its journey from A and ends the journey at B. And ends the journey at point B. I am just going to draw the perpendicular. Hope I just show you the same graph in the previous class too. So I am just writing it as C. And again I am going to write the perpendicular. This perpendicular is taken as D. Dear students, when the object is going to start its journey, it means at this point the time is equal to 0. The time is equal to 0. But when it stops its journey, by the time is equal to t. So that the distance between O and C, that is said to be the time taken between these 2 points, that is initial and final point, is taken as t. Then OC is parallel to AD. So thus term AD is also equal to t. Similarly, AO is parallel to DC. So this value is also equal to u. I said you that the object is going to end its journey at B. When it is going to end its journey, the final velocity is considered as v. The final velocity is considered as v. Now, therefore, the BC is taken as v. What is the value of BD then? So the value of BD can be written as v minus u. V minus u gives you the value of BD. So let note it down. I want to just note all the things which will come under this graph. AO is equal to DC. So I am writing here AO is equal to DC, which is equal to u, because those two are parallel. So those values is equal to u. So I have to write here itself. AO is equal to BC is equal to u. Similarly, AD and OC are parallel. So that AD and OC are parallel, whereas both are equal to small t. And now BC is equal to V, BC is equal to V, and the value of VD, that is said to be value of VD is equal to V minus U. Otherwise, value of VD can be written as BC minus DC. So first write that BC minus DC. So BC minus BC. So what is BC here? BC is V. Okay, the value of DC is V and the value of BC is U. So that the value of VD is said to be V minus U. Finally, we noted down what are the things which was present in the graph. Now let us continue. So what we should do now? Now we should proceed for the derivation of these three equations. Now my dear students, first I am moving towards the derivation of the first equation of motion, that is S is equal to ut plus of at square. I want to derive this equation. Here you can observe that S is said to be the displacement, u is initial velocity, t is time, a is acceleration. Now here already there is a presence of displacement and you know that if you just calculate the area under the VT graph, it gives you displacement. I said you already that. I written here the 2 points already. In that I just showed you that the area under the graph gives you the displacement. So I think you got the idea, if we just calculate the area, it's enough to get this equation. Now let us see that. Let us see that A, B, D, C, O, A. It is said to be the trapezium. Now, I just want to calculate the area. Area under the curve AB. Whereas AB is a curve, so the area which is bounded inside this curve gives you displacement. Gives you displacement. Right? Now, I am just writing this displacement here. So, displacement is represented by symbol S. I just want to write the area now. What is the area which was present under this curve AB? So, under this curve AB, we have A, B, C, O, A as a trapezium. So, just I want to write the area of trapezium. Area of trapezium A, B, C, O. A, B, C, O. Right? See, just by using this also you can calculate. Either you can split and you can calculate it very easily. See, in this trapezium we have two types of one is triangle and another one is said to be the rectangle. Here you can observe A, B, D is said to be the triangle and A, B, C, O is said to be the rectangle. So I can split it into two types. So area of triangle A, B, D plus area of rectangle. Area of rectangle A, D, C, O. A, B, C, O. Right? Now S is equal to, oh my dear students, here it is area of triangle ABD. You know that the area of triangle can be written as of into base into height. Of into base into height plus the area of the rectangle that can be written as length into breadth. S is equal to. Now let us see the diagram. So area of the triangle ABD. Observe this one. ABD. Just observe this. Base is said to be AD. Height is said to be BD. So just now I am writing. So AD is the base. AD into height is said to be BD. BD is height. Plus. Now you can observe what is the length. Length and breadth in rectangle A, D, C, O. AD is the length, or OC is the length. You can construct anything. So I am just writing OC is the length into. You can observe breadth. Breadth is taken as AO. Breadth is taken as AO. Right? Now, S is equal to of into. What is the value of AD here? The value of AD is T. So substitute here into. What is the value of BD? It is said to be B minus U. It is said to be B minus U plus now remaining OC into AO. What is the value of OC? It is T. Substitute. And what is the value of AO? It is said to be U. Substitute the same thing here. S becomes equal to. S becomes equal to. Here it is UT, right? So just write UV to T becomes UT plus. Here it is of. Here it is T. Then what is B minus U? Dear students, you know that there is another one equation of motion. There is another one equation of motion that is said to be V is equal to U plus AT. So by using this equation, we can substitute that. I will show you that method. See, we have the second equation that can be written as V is equal to U plus AT. I want to substitute. I want to separate this. I want to replace this V minus U. If I shift this plus U towards LHS, what happens now? It becomes V minus U, which is equal to 80, right? Now, then here exactly V minus U can be replaced by 80 here. V minus U can be replaced by 80 here. So, I just derived this by using this another kinematic equation of motion. Rather than moving with this, even we can use the definition of acceleration. You know that the acceleration can be written as change in velocity by time taken. So this is from equation of motion. This is from equation of motion. Whereas this is from definition of acceleration. This is from definition of acceleration. So I want V minus U, right? So V minus U can be written as A into T. You can use any one method to substitute V minus U. So I just use the equation of motion to get the value of V minus U, which is equal to 80. And I used another one method, that is definition of acceleration. There also I got the value of V minus U is equal to 80. You can use any one method. Therefore, because A is equal to V minus U by T, so that V minus U can be written as A into T. I am just writing here, in place of V minus U, I can write it as AT. Now, in the next step, S is equal to UT plus of AT into T becomes AT square. AT into T becomes AT square. So this is a required equation. S is equal to UT plus of AT square. So finally, we deduce the expression for the first equation of motion, that is S is equal to UT plus of AT square. Now dear students, now let us move towards the next equation of motion, that is V is equal to U plus AT. Sorry, let me put up this. So now I am just writing it over here. Now just move towards the next equation of motion. Now the next equation of motion is V is equal to U plus AT. Right? I am moving with this equation now. To derive this, it's very easy, my dear students. Why? Because here we have the velocities, right? So simply, just by calculation of a slope, of the VT graph, we can move towards this equation. So now, I am just moving towards the calculation of slope over here. Slope of curve AB, gives you acceleration. Hope you got slope of curve AB gives you acceleration. I am just writing here acceleration. Why, my dear students? You can ask me the question. So that here we have curve AB. If we calculate the slope, what will get? Acceleration. Why? Because this is a velocity time graph. Slope of velocity time graph always gives you acceleration. Slope of velocity time graph always gives you acceleration. So that the acceleration is represented by the symbol small a. Now, the slope of the curve AB. How to calculate the slope? So, in the previous class, I just shown you the calculation of the slope. The slope can be calculated just by taking tan theta or just by writing it by y by x. So here the slope can be calculated as, here the y-axis is BD and the x-axis is AD. So here in place of slope, I am writing it as y by x. So which one is the y-axis in the slope here? So in this you can observe this. The slope of this one, ABD, BD is said to be the y-axis and AD is said to be the x-axis. So BD divided by AD. So in the previous class I showed you how to calculate already. So once I will just show you here again. So that this is said to be the graph ABC. Here how to calculate the slope. Slope can be written as tan theta. And even it can be written as y by x. So y-axis is AB here. So and x-axis is BC here. AB by BC. This is how I showed in the previous class. So the same thing I am writing over there. So that BD by AD. What is the value of BD now? Here I already written that the value of BD is equal to V minus U. Substitute it. V minus U divided by, what is the value of AD? It is said to be T. Now it is said to be T. Let us cross multiply the terms. So V minus U becomes equal to 80. V minus U becomes equal to 80. I am going to take this minus U towards this side. It becomes plus U. So V is equal to U plus 80. This is said to be the second equation of motion, where V is final velocity, U is initial velocity, A is acceleration, and T is the time consumed by the object. This is about the second equation of motion. And my dear students, now let us move towards the calculation of the derivation of third equation of motion, that is V square minus U square is equal to 2AS. Dear students, the same thing I am going to follow again. You know that if we calculate the slope of the curve LBT graph, we will get the acceleration. So that the slope can be written as y by x. Here the side which is parallel to the y-axis is BD and the side which is parallel to the x-axis is AD. Then the acceleration A can be written as BD by AD, whereas BD is taken as B minus U from the graph and AD is taken as T, and just by cross multiplication I got V minus U is equal to 80, and again just by shifting the minus U towards the RHS, we will got V is equal to U plus 80. So I am continuing again from here. So for the derivation of V square minus U square equals to AS, I should follow this method, and now what I am doing, just observe it here. Yes. So it has equation number 1. Now I am squaring equation 1 on both the sides. Squaring equation 1 on both sides. I am just squaring it out. So what happens now? V squared is equal to U plus 80 V square. Observe carefully that U plus 80 whole square. It is in the form of A plus B whole square. So from the mathematics, that can be written as A square plus B square plus 2AB. Right. See, A square is U square, B square is A square T square, and 2 into A is U and B is A into T. So now V square equals U square, right? Rather than writing this, I just want to shift it over here. So if I shift U towards this side, it becomes minus. So I got the LHS part. The next thing is I should get the value of 2AS. Let us do the circus for that. So the remaining terms are A square T square plus 2UAT. Then which are the common terms present here? So A, T, A, T. Both are the common terms which was present here. So just let us try to take out the common terms outside. Otherwise, what I am doing, I just want to keep these terms there itself and I can take 2U outside. You can make this, even you can solve this just by using 2 different methods, or even you can solve this just by placing the value of 2 here itself and just by taking 80 outside. So 2 or 3 different methods you can do. Just I will show you one method so to get clear and to get mastered over this derivation. I'm just going to take, see here, I'm just going to take 2A outside. I'm just going to take 2A outside. Suppose if I take 2A outside, observe carefully. 1A came out, remaining is another A, and T square will be there as it is. But 2 is not there here, so it becomes to the denominator. Plus 2A I removed outside, remaining is UT. Hope you got 2A is outside, so remaining is UT. and here a is outside, remaining is a and remaining is t square. And I just take 2 outside. So for that reason, here there is no 2. For that reason, it becomes to the denominator, that is 1 by 2. We can observe that ut plus of at square. This is in the form of ut plus of at square. You know that there is a first equation of motion, that ut plus of at square is equal to displacement, that is said to be s. I am replacing s over here, so that v square minus u square is equal to 2a into s. Finally, we have the third equation of motion. So these are the 3 equations of motion. For the first equation of motion, what I did, I just calculated the area under the curve just by splitting the trapezium into 2 different parts, one is a rectangle and another is triangle. And for the second equation of motion, I just calculated the slope. By calculating the slope under the curve VT graph, I got acceleration. So similarly, for this, I calculated the slope. After calculation of the slope, squaring, and finally substituted the value of this ut plus of at square, and I got this v square minus u square is equal to 2as. So this is about the 3 kinematic equations of motion. Dear students, these 3 equations of motion is exactly applied for the objects which are just moving in an horizontal path. So even I can say that if we just apply the force, the ball, so it moves from one position to another position. If we just apply the force on a box, it displaces its position. So by the time we can use these kinematic equations of motion. But sometimes what happens, so we are not only observing the motion of the object exactly on the ground, exactly in the horizontal direction. Sometimes even we may stand on the tower and we can drop the ball. Even we can stand on the tower and we can throw the ball. By the time, the 3 equations of motion, they are going to change. How? Let us see that. For that, I am just going to write the 3 equations of motion again. V is equal to u plus at, s is equal to ut plus of at square, and the third one is v square minus u square is equal to 2as. Students, observe carefully. I said that suppose if I just stand on the tower, and I am throwing the ball. Assume that I am just standing on the tower and I am going to throw the ball towards the downward direction. Then what happens, in this position, the acceleration A becomes equal to g. Then what is this g, ma'am? G is said to be acceleration due to gravity. It is said to be the acceleration due to gravity. Then A is equal to g here. It means the ball is attracted by the earth due to the gravitational force. The acceleration acquired by this ball is exactly due to the gravity called as acceleration due to gravity, represented by small g. Now A becomes equal to g, right? Then this ball displaces from this top of the tower to the ground. After some time, it reaches the ground, right? After some time, say t, it reaches the ground. After some time, say t, it reaches the ground. So then, by the time, we should calculate the displacement. So from this point to this point, how much distance is covered by the object, by the ball when it thrown from the top of the tower? Then, by the time, we should not use the displacement. Yes, we should use the word h, that is height. It is said to be height. So now, in this equation, I am going to replace s by h and a by g. Let us see here these equations of motion for an object which are under free fall. It means the objects which are falling under the action of gravity. For those objects, the equations of motion turns out to be in this way, that is v is equal to u plus gt. The second one is H is equal to ut plus of gt square. Observe carefully, I am just replacing a by g and s by h, and the last one is v square minus v square is equal to 2gh, because a becomes g and s becomes h. So this is about the three equations of motion which were exactly required by the objects which are under free fall, which are falling under the action of gravity. Okay, now let us move towards how actually the initial velocity and the final velocity takes place exactly for an object where it is thrown from some height. Exactly, now you can observe the same diagram over here. So now assume that I am going to throw the ball by standing on the top of the tower. What happens by the time when we are standing at some height? Here, if I just throw the object from this position, the initial velocity becomes equal to, see, when we come towards any position, suppose if the object is moving from one point to another point, say A to B, by the time the velocity at the point A is initial velocity u, and the velocity at the point B is taken as final velocity v. Similarly, here also when the object is falling from some height to the ground, the initial velocity at this position is u and the final velocity at the ground is taken as v. Keep in your mind. If the objects come to rest, if the object come to rest so that the final velocity becomes equal to 0. And if this object is going to start its journey from the rest, that is taken as initial velocity becomes equal to 0. Keep in your mind that if the object starts its journey, starts moving from rest position, then the initial velocity is taken as 0. If the object comes to the rest, at the time the final velocity is taken as 0. So, yaವಾಗ initial velocity and the final velocity 0 ತಗೋಬೇಕು, there is a condition that when the object comes to the rest after the motion, that in the final velocity is to be equal to 0, and when the object starts its journey from the rest, by the time the initial velocity becomes 0. But here, when the object is thrown from a height, it acquires some initial velocity. Why? Because you are going to throw an object from here. So it means if you just throw the object by standing on the top of the tower, by standing on the building, so that by the time, what happens to the initial velocity? What happens to the velocity of that object which was thrown? So it is going to acquire some velocity. That velocity is taken as initial velocity represented by u. Hope you got. So that the other object, when you stand on the tower and you are going to throw it, so it is going to acquire some velocity, said to be the initial velocity u. If the object comes to rest, final velocity is 0. If the object starts its journey from the rest, initial velocity u becomes equal to 0. So these are some points which are required just to solve the numericals, right? So this is about 3 equations of motion. And when we come towards the graphical point of view, my dear students, I just discussed you 4 graphs, especially related to the velocity time graph. And even we can discuss the position time graph also. So that before going towards the position time graph, so now I just want to show you that the graph which was discussed in the previous class, that is the time along x-axis and the velocity along y-axis, said to be the VT graph. If I just consider that, the graph or the curve AB is parallel to the x-axis, at this time the initial velocity u and the final velocity v both are same. so that the acceleration becomes equal to 0. I said it in the previous class, right? So that acceleration is 0 here. It means the object is moving with constant velocity. It is moving with constant velocity. Similarly, position time graph. I am just writing the position time graph. We can observe that along x-axis time and along y-axis distance. I am going to consider. Suppose if I write the curve AB, which is parallel to the x-axis, in position time graph, I am comparing these two in position time graph. So what happens here? The position is same at all the points. It means the object is not moving. See here, the position is 2 meter when the time is 1 second. The time is 1 second and the 2 seconds, 3 seconds, 4, 5, 6, 7 at all the time. The object is exactly in the same position. It is not moving. This shows that the object is in the rest. This shows that the object is in the rest. My dear students, I already said if I calculate the slope of BT graph, I will get acceleration. Similarly, if I calculate the slope of distance time graph, I will get the velocity. I will get the velocity. And similarly, if I calculate the area again, I will move towards calculation of displacement here. Keep in your mind, the slope of BT graph gives you acceleration and the slope of ST graph, this position time graph, gives you velocity. So I just compared the two graphs, right? Thank you, students.